What actually happens when a dollar bill dies? It's a fascinating, tightly controlled process. But, to really appreciate the death of the dollar, we have to rewind and look at its birth.
Section 1. Roots of the greenback. The birth of modern U.S. currency.
It is honestly wild how far back this technology stretches. Back in 1775, during the American War of Independence, none other than Paul Revere used his engraving skills to make the printing plates for the very first versions of U.S. paper money. The paper itself, that came from Stephen Crane, a papermaker and freedom fighter whose family legacy is literally still woven into our currency today. By 1844, his descendant, Zenas Marshall Crane, figured out a way to embed actual silk threads straight into the banknote paper to signify its denomination. Fast forward a bit to the Civil War in 1861, and the U.S. started issuing demand notes with this very distinct green ink on the back, which is exactly how they got the famous nickname, greenbacks. All that chaos of different state and private notes finally settled down in 1914, when the brand new Federal Reserve issued the first official Federal Reserve notes.
Okay, and here is a completely mind-blowing fact for you. Back in 1929, they decided to standardize things and cut production costs, so the entire bill design was actually shrunk by 30% to the size we use today. But here is the crazy part. Despite that massive design change, every single US dollar issued since 1861 is still legally valid right now. Literally, not a single one has ever been officially canceled. Pretty amazing, right? But how are today's standardized bills actually physically made? Let's take a look at the factory floor.
Section 2. Printing, Offset, and Intaglio. The art and engineering of cash.
The sheer scale of this operation is hard to wrap your head around. It mostly happens at the Bureau of Engraving and Printing, the BEP, in Washington, D.C., though they also have a massive facility down in Fort Worth, Texas. For over 150 years, the BEP has been the birthplace of our money. At any given second, there can be up to $300 million just sitting inside their high-security vaults, literally just waiting for the ink to dry. Now, getting that ink on the paper relies on a mashup of two totally different printing technologies. First up is offset printing. Think state-of-the-art, 50-foot-long rotary presses churning out 10,000 sheets an hour. This step lays down those flat, super complex geometric background colors, like those subtle purples and golds you see on the modern $20 and $50 bills. Then we have the master stage, intaglio printing. This uses deeply engraved steel plates and extreme physical pressure to give the paper a distinct, raised texture. So how does this build layer by layer? Well, currency printing is basically an exercise in patience. Step 1 is that offset printing we just talked about, putting down the background colors. Once that's done, those sheets have to cure in a vault for a full 72 hours. Then comes step 2, where the back of the sheet is printed with green ink using the heavy-duty intaglio process. After that, you guessed it, back into the vault for another 72 hours of drying. Finally, we hit step 3, the face intaglio. This is where special cutout ink rollers apply the black ink for the borders and portraits, along with those fancy metallic or color-shifting inks.
And here is where the money really gets its soul. Those intaglio presses, they weigh 57 tons. They literally force the paper into ink-filled grooves in the steel plates using up to 5,000 pounds of pressure per square inch. That is an unbelievable amount of force. It physically deforms the paper itself, pulling the ink out of the grooves and leaving a raised, finished image. When it completely dries, that tactility feels almost like a really fine sandpaper. It's an incredible engineering marvel happening right on the surface of your cash.
Section 3. Uncrackable security features, the arms race against counterfeiters.
So that unique sandpaper-like texture from the intaglio presses, that's actually a massive headache for counterfeiters to try and duplicate. But the BP doesn't stop there. Every bill higher than a $2 bill has a security thread physically embedded inside it. Take the $5 bill, for example. It has a thread stamped with USA and 5 in an alternating pattern. You can see it from both sides if you hold it up to a light. But here's the cool part. If you throw it under an ultraviolet light, that exact thread brightly glows blue. And this security isn't just physical, it extends right into the digital world. Modern bills feature something called the Urian constellation. Basically, this is a highly specific, super subtle pattern of symbols perfectly hidden in the artwork. And get this, commercial scanning software and modern photocopiers are specifically programmed to recognize that exact pattern. If they spot it, they physically refuse to copy the image. It is a hard stop against high-tech counterfeiting. But even with all of this unbelievable tech, the BEP doesn't just assume everything printed is perfect. Before any money leaves the factory, it runs through the offline currency inspection system.
We're talking ultra-high-resolution cameras scanning both sides of the bills simultaneously at a lightning-fast speed of 2.5 sheets every single second. If it detects even a microscopic irregularity, a mechanical arm swoops in and flags the defective note so it can be pulled out. They make absolutely sure only flawless currency gets out the door.
Section 4. Retirement and ultimate destruction. The end of the road. Fast forward years later. Eventually, these bills limp their way back from commercial banks to a Federal Reserve Bank, and they have to face a really rigorous fitness test. Sensors are checking for tears, built-up grime, missing edges, fading ink. They even measure the thickness of the paper itself, because as a bill gets worn down over its life, it literally gets thinner. If a bill fails this test, a mechanical arm instantly diverts it. Its career is officially over. And I hate to break it to you, but contrary to Hollywood heist movies, there are no giant dramatic incinerators with huge flames for rejected cash. Modern destruction is completely organized and heavily controlled.
Instead, those rejected bills are fed into these massive industrial-grade shredders that just absolutely chew through the currency, turning it into tiny, unrecognizable confetti. The shredding pattern is so precise that reassembling a single bill is completely impossible. And the skill here is just staggering. The Federal Reserve shreds 7,000 tons of worn-out currency every single year. To put that into perspective, that is the weight of thousands of cars just in shredded paper. And they track every single ounce of it down to the exact gram. But plot twist, that isn't actually the end of the story. Those shredded pieces of cash get a surprisingly useful second life. Depending on where you are, the Fed recycles this literal mountain of destroyed money into fuel pellets, packing material, or even agricultural compost for farming. In a few cities, you can even buy little bags of shredded money as souvenir confetti. And of course, while all this is happening, the Federal Reserve is already ordering fresh replacements, sending the BEP back to work to keep the whole cycle spinning. So we have finally come full circle, all the way from Paul Revere's early copper plates through those massive 57-ton intaglio presses down to a highly precise 7,000 tons shredding operation at the Fed. So next time you pull a dollar out of your pocket, take a second, run your thumb across that ink. Think about it. Can you feel the thousands of pounds of pressure that brought it to life? Can you spot the layered offset colors or that glowing security thread hidden right inside? That little piece of paper in your hand is an absolute marvel of history and engineering. Thank you so much for joining me for this explainer, and I highly encourage you to never look at your spare change the exact same way again.